Today we're going to be practicing finding percent compositions for different compounds. This first compound that I have is of glucose. I have C6H12O6. And what I'm going to do first is I'm going to find the molar mass of this complete compound, and I'm going to be extra carefully sure that I am actually writing down the individual masses for each piece, so that I can find that proportion at the end. So I went ahead and I wrote out each element that is present in the actual compound. Then I'm going to steal their their subscripts and write those as well. And then I will be multiplying their subscripts by their mass from the actual periodic table. And adding that up. So carbon is going to have a mass of 12.011. .011 times 6 gives me the number 72.066. Hydrogen is going to have a mass of 1.008. So then I will do 12 times 1.08. That gives me the number 12.096. And then oxygen has a mass of 15.999. And 6 times 15.999 will give me 95.994. So now I have all of my individual pieces, and I can go ahead and add those up and find my total. Add all those up. So that would be 72.066 plus 12.096 plus 95.994. And that gives me a total mass for the compound of 180.156. I'm not going to bother attaching a unit because this isn't my desired answer, so I don't want to clog up my paper with units. But if you are curious, the molar mass unit should be grams per mole. So now I'm going to go ahead and do the calculations for percent carbon. So for percent carbon, what I'm going to do is I'm going to take carbon's piece, which is going to be 72.066. I will be dividing that by my total mass, which was 180.156. And then I'm going to be multiplying the entire thing by 100. And that will give me my percent. So 72.066 divided by 180.156 times 100. That gives me the percentage 40, and then I'm going to round to that second decimal place. 1 does not make me round up, so I'm just going to go ahead and leave it at 40.00%, and then I'm just going to be extra careful and put carbon. Then I'm going to go ahead and calculate for percent hydrogen. So hydrogen, I'm going to have the 12.096. I'm going to be dividing that by the total mass of the compound, which was 180.156, and I'll be multiplying that thing by 100. So 12.096 divided by 180.156 times 100. I'm going to be rounding to that second decimal place again. 4 does not make me round up, so I will leave this at 6.71%, and then I'm just going to be careful and label it hydrogen. I didn't really give myself enough room to work it out the exact same way for oxygen over in this space, so I'm going to like kind of move myself over here, because apparently spatial things are difficult today. So 95.994 and I'm going to be dividing that by the total mass, which was 180.156. And I'll be multiplying that whole thing by 100. So 95.994 divided by 180.156 and multiplied by 100. That will give me, I'm going to have to write it down. That will give me 53.2, and then 3 does not make me round up, so 8, and then percent, and then oxygen. Just as a general thing, whenever you get your percentages, they should add up to either exactly 100% or close to it. Since we rounded, they're not actually going to end up adding up perfectly, but we can just make sure that we're at least close. But rounding will make this slightly off, okay? But we have 99.99, and that's going to be close enough to 100%. It means we did our math correctly, just where rounding ended up being made our number slightly off. Okay, so the next thing I'm going to do is I'm going to calculate the percent composition for sodium phosphate. I'm going to do the exact same thing that I did up here, hopefully with a little bit of better spatial recognition this time. So sodium, I have 3 of them. Phosphorus, I have 1. And then oxygen, I have 4. So sodium's mass from the periodic table is 22.990. That gives me the number 68.97. Phosphorus's mass on my periodic table is 30.974. And 1 times any number is just going to be that number, so 30.974. And then oxygen's mass from the periodic table is going to be 15.999. Four times 15.999 will give me 63.996, and then I'll go ahead and add all of those up. So 68.97 plus 30.974 plus 63.996 gives me a total mass of 163.94. Again, I'm not going to bother with units, but if I wanted units, it would be grams per mole. So now that I have that, I can go ahead and perform the remainder of the calculation for the percentages, the thing that I actually care about for this problem. So I'm going to start off with percent sodium. I'm going to have sodium's mass for all 3 of those sodiums, 68.97. I'm going to be dividing it by the total mass of the compound, 163.94, and then I will be multiplying that by 100. So 68.97 divided by 163.94 times 100 gives me the number 42.07. Rounding to the second decimal, that 0 doesn't make me round up, so I'll leave it. And then percent, and then I'll go ahead and label it as percent sodium. Next, I will do percent phosphorus. So phosphorus's part is 30.974. I'll divide it by the entire mass, 163.9794. Oops. And then I will be multiplying that by 100. So 30.974 divided by 163.94 times 100. And again, I'm going to be rounding to that second decimal place. 3 does not make me round up, so this will be 18.89%, and then this was phosphorus. Last but not least, I gave myself enough room this time, so I'm going to be able to do it all at once. Percent oxygen, I'm going to have oxygen's mass, which is 63.996. I'm going to be dividing it by the total mass of the compound, 163.94, and then I'm going to be multiplying that by 100. So 63.996 divided by 163.94 times 100. That will give me the number 39.06, makes me round up, 4% oxygen. Just as a check, I'm going to add these together, make sure I'm at least close to 100. Perfect. So my rounding to the second decimal didn't mess me up here. So we are good to go. On to the next question. I am asking for percent composition for silver nitrate. So yet again, I will go ahead and do silver. I only have one of them. Nitrogen, I only have one of them. Oxygen, I'm going to have 3 of them. And then I'll look on the table. Silver's mass will be at 107.868. One times any number is going to be that number, so 107.868 is silver's portion. Nitrogen's mass from the periodic table is 14.007. And 1 times any number, so 14.007 is again nitrogen's portion. And oxygen's mass is going to be 15.999. And this is the only one I'm going to have to put into the calculator since it's not multiplied by 1. So 3 times 15.999 gives me 47.997. And then I'll add all of those up. So 107.868 plus 14.07 plus 47.997. That gives me the number 169.872. So now I can go ahead and move on to my percentages. So first up, I have percent silver. I'm going to have 107.868 divided by my total mass, which was 169.872, and then multiplied by 100. Okay, so 107.868 divided by 169.872 times 100 gives me 63.4. Actually, this is going to round up because I'm going to round to that second decimal place. So that's going to give me a 63.50%. Since I'm rounding to that second decimal place, 9 makes me round up, so that 9 is going to turn into a 10, and it's going to turn into a 5. So percent silver. And then I can do nitrogen. So percent nitrogen is going to be 14.007 divided by 169.872 times 100. That gives me 8.25, makes me round up, 5%. And then percent oxygen is next. So 47.997 divided by 169.872 times 100. That will give me a percentage of 28.25. 4 doesn't make me round up, so percent. And then I can go ahead and add those up. So 63.5 plus 8.25 plus 28.25 gives me a perfect 100. Last problem that we're going to go ahead and do is going to be the percent composition for tungsten 1 nitrate. Same procedure. Tungsten, I only have one of them. Nitrogen, I only have one of them. And oxygen, I have 3 of them. Tungsten is going to weigh 183.84. And 1 times any number is going to be that number, so 183.84. Nitrogen, I'm going to just go ahead and steal these masses from up here since we're using the same compound. So 14.007, 1 times 14.007 is 14.007. And oxygen, its mass is 15.999. 3 times 15.9, I already did that, is 47.997. Then we'll add them up. So 183.84 plus 14.07 plus 47.997 gives me 245.844. And then I can do my percentages. So percent tungsten is going to be equal to 183.84 divided by my total mass of the compound, 245.844 times 100. So 183.84 divided by 245.844 times 100. Gives me 74.78, since 9 makes me round up, percent tungsten. Percent nitrogen is going to be 14.007 divided by total mass of compound, 245.844 times 100. That gave me 5.6. Actually, 7 makes me round up, so that's going to be 5.70 percent nitrogen. And then my percent oxygen is going to be 47.997 divided by 245.844 times 100. And that gives me a mass of 19.52. 3 doesn't make me round up, percent oxygen. So then I'm just going to check to make sure everything's good. So 74.78 plus 5.7 plus 19.52 gives me exactly 100. So these are correct.